We're going to finish up chapter 14 today, liquids and solids, with looking at the solid state, types of solids, 14.5, and bonding in solids. It's a really quick lecture. Crystalline solids is where we're going to start. This is the solids that have a regular arrangement of their components, and we see this in sodium chloride really. If you were to take a salt shaker and to shake the salt grains out into your hand, you would notice there are these little cubes, and those have a regular arrangement because it is sodium chloride and because we see the different faces of that crystalline solid when you look at the actual salt in your hand. So if we're going to classify crystalline solids, we look at whether they are ionic, molecular, or atomic. And it just makes sense that ionic solids have components that are ions, just like we saw in the sodium chloride. The molecular solids are going to be made up of molecules, and the atomic solids are going to be made up of atoms of one particular type of substance. Ionic solids, they are ions at the point of the lattice that describe the structure of the solid, where molecular solids at the point of the lattice, we have discrete covalently bonded molecules, and atomic solids, they have atoms at the lattice points to describe the structure. And here's three examples. The diamond, which is the atom, and it has a carbon atom at each point of the lattice. We see sodium chloride with an ion at each point of the lattice, and here we have ice, which is covalently bonded, and we see a compound that is covalently bonded, or a molecule at each point. Some examples of various types of solids, whether they're ionic, molecular, or atomic. That gives you some examples to look at. Let's look at what happens within an ionic solid. What kind of characteristics should we expect? Well, ionic solids are stable substances and they have high melting points. If you go to melt salt, sodium chloride, it's not going to melt very easily at all because it melts at a very high melting point. It's held together by strong forces between the ions. On the other hand, if we have a molecular solid, the fundamental particle is a molecule, and those tend to melt at relatively low temperature. So an example of this would be table sugar, for example. If you're not careful, you actually can scorch sugar when you go to melt it. So molecular solids have low melting temperatures, and they're held together by weak intermolecular forces, which allows them to have a lower melting temperature. Atomic solids, the fundamental particle is the atom, and it really depends on what type of atoms you're looking at. If you're looking at group 8, they have low melting points. If you look at a diamond, which is made up of carbon, it has a very high melting point. So it really depends on the type of atom. So what goes on when you bond between metals or within metals? Metals are held together by non-directional covalent bonds, and this is referred to as the electron C model. Metals form alloys of two types, and metal alloys are if you were to take them and mix them together. These aren't chemical bonds within an alloy, they're a mixture. So a substitutional alloy is when you take different atoms that get substituted for the host metal. So in this case, we have copper atoms and zinc atoms, very similar in size, and you notice that the zinc has been put in as a substitute for carbon, and this is called substitutional alloys. On the other hand, interstitial alloys are when we have small atoms that get introduced into the holes of a metallic structure and increases the strength of that metal. So we have iron, which is much larger than the carbon atoms, and you put the carbon in between, and you notice that that will give us a structure, an alloy that's going to give us a stronger structure. That's going to conclude the bonding in solids and bonding in metals for chapter 14. So we're finished with this chapter, ready to review for the test.